Welcome to Vedavyasa Academy. Here, our session is functions, long answer questions for IPE. One more important update for you. So, important update అయితే మనకు బోర్డ్ ఆఫ్ ఇంటర్మీడియట్ నుంచి వచ్చింది. ఎవరైతే అడ్మిషన్స్ మిస్ అయిపోయినరో, అడ్మిషన్ ఇంటర్మీడియట్లో అడ్మిషన్స్ తీసుకోవడం మిస్ అయిపోయినరో అటువంటి వారు, లేకపోతే ఒక కాలేజీ నుంచి ఇంకొక కాలేజీకి ట్రాన్స్ఫర్ కావాలనుకున్న వాళ్ళు, ఇప్పుడు కొత్తగా అడ్మిషన్ షెడ్యూలు మళ్ళీ నవంబర్ 10th వరకు బోర్డ్ ఆఫ్ ఇంటర్మీడియట్ అడ్మిషన్ షెడ్యూల్ ప్రకటించింది. సో ఆల్ ద స్టూడెంట్స్, యూ రిమెంబర్ దిస్ వన్. Okay, all of you. So you observe this one. So this is the update from Intermediate Board of Intermediate Education. I already posted a detailed copy in short in YouTube. So here now function chapter nunchi long answer question 5 questions are completed. This is the 6th question. So these are the very important questions. Very important questions, repeated question in Board of Intermediate Examination. IPE problems from function. Long answer question. So here 6th question. Now we are discussing 6th question in this session. So 6th problem, first one, first part. This is the first part, this is the second part. First part of the question, if R to R, G R to R, if function from f is the function from R to R, G is the function from R to R, are defined by f of x is equal to 4x minus 1 and g of x is equal to x square plus 2. Then find first one g circle f of x, second one g circle f of a plus 1 by 4, third one f circle f of x, fourth one g circle of f circle f of 0. This is the first problem. Sixth, first part of the problem. Second part of the problem, this is let a is equal to set of 1 2 3, b is equal to set of a b c, c is equal to set of p q r. If f is a function from a to b, g is function from b to c, are defined by f is equal to set of order pair 1 comma a, 2 comma c, 3 comma b, and g order pair a comma q, b comma r, c comma p. Then show that f inverse circle g inverse is equal to g circle f whole inverse. So we want to solve these two problems. So first we want to solve first part of the sixth problem. First part of the sixth problem. Here first part of the problem, this is if f function f from R to R, g R to R are defined by f of x is equal to 4x minus 1 and g of x is equal to x square plus 2, then find the value g circle f of x, g circle f of a plus 1 by 4, third one f circle f of x, fourth one g circle of f circle f of 0. We have to find these problems. So what given here, you write first here, that is f is the R to R function, g is the R to R function. Means what? F is the real valued function, g is the real valued function, and given f of x is equal to 4x minus 1, g of x is equal to x square plus 2. Okay, all of you, you find this one first. So First one, G circle f of x is equal to G of f of x. Okay, all of you. G circle f of x can be written as G of f of x. So, this is equal to G of, what is f of x? F of x is equal to 4x minus 1. Here, 4x minus 1. So 4x minus 1 f of x value. So what is g of x? G of x is 4x square plus 2. So instead of x, you substitute 4x minus 1. So you substitute here 4x minus 1. 4x minus 1 whole square plus 2. In x place you substitute 4x minus 1, then 4x minus 1 whole square. This is in the form of a minus b whole square. A minus b whole square is equal to a square minus 2ab plus b square. Then you have to substitute 4x whole square minus 2 into 4x into 1 plus 1 whole square plus 2 is there. So 16x square minus 8x plus 1 plus 2. This is equal to 16x square minus 8x plus 3 is the answer. So what is the G circle f of x? G circle f of x is equal to what? 16x square minus 8x. 16x square minus 8x plus 3 is the answer. So first one, G circle f of x is equal to 16x square minus 8x plus 3 is the answer. Once again you see all of you. So G circle f of x is equal to G of f of x. But what is f of x? 4x minus 1. So you substitute G of 4x minus 1. Instead of x you substitute 4x minus 1. Then 4x minus 1 whole square plus 2. This is in the form of a minus b whole square. A square minus 2ab plus b square. Then you expand this one. 4x square minus 2 into 4x into 1 plus 1 square plus 2 is there. So 16x square minus 8x plus 1 plus 2. 16x square minus 8x plus 3. G circle f of x equal to 16x square minus 8x plus 3 is the answer. You go for second problem. This is the second problem. So what is second problem here? G circle f of, this is a plus 1 by 4. So G circle f of a plus 1 by 4. You substitute here, instead of x, a plus 1 by 4 is equal to G of, what is this one? 4 of x value a plus 1 by 4 minus 1 here. This 4 cancel. Okay, all of you. This is G of a plus 1 is remaining, minus 1 is there. Minus 1 plus 1 cancel. G of a. Okay, all of you. But what is G of x? G of x is equal to x square plus 2. G of x is equal to x square plus 2. Then G of a is equal to what? Instead of x, a is there. So a square plus 2. Therefore, what we can written as G circle f of x is equal to f of a plus 1 by 4 is equal to a square plus 2. Okay, all of you. G circle f of a plus 1 by 4 is equal to a square plus 2 is the G circle f of a plus 1 by 4, second one. Okay, all of you. Next, third one. This is the third one. What is third one here? You write here f circle f of x. Okay, what is third one here? F circle f of x. This f circle f of x can be written as f of x is equal to, what is f of x? 4x minus 1. This is equal to f of 4x minus 1. Okay, all of you. Here f of 4x minus 1. Instead of x, you substitute instead of x 4x minus 1. That is 4 into 4x minus 1 is there. 4 into 4, 16x. 4 into 1, minus 4. This is minus 1. This is 6x minus 5 is there. So, what we can conclude that is f circle f of x is equal to what? 16x minus 1 is the answer. Then after you find this one. Then after you find fourth one. So what is fourth one? Fourth one is what? G circle f circle f of 0. G circle f. So what we can write this as? This as G of f of 0. Okay. Here what is f of 0? F of 0, f of x is equal to 4x minus 1. F of 0 is equal to, when x is equal to 0, this is 4 into 0 minus 1 is equal to minus 1. So here f of 0 value minus 1. So what? This can be written as, this is implies g of f of minus 1 is there. Why? Because f of 0 value is minus 1. So f of x is equal to what? 4x minus 1. So x is equal to minus 1. F of minus 1 is equal to 4 into minus 1 minus 1. Minus 4 minus 1 is equal to minus 5. Is equal to what? Minus y. F of minus 1 is equal to minus y. You substitute here. This is implies g of minus 5 is equal to, what is g of x? G of x is equal to x square plus 2. G of x is equal to x square plus 2. So minus 5 whole square plus 2, 25 plus 2 is equal to 27. So is equal to what? 27 is there. Therefore, G circle of F circle F of 0 is equal to 27 is the answer. Okay, all of you. That's all. To see all of you. Second part of the problem. First part of the problem completed. Now second part of the problem. Let A is equal to 1, 2, 3 set. B is equal to set A comma B comma C. C is equal to P comma Q comma R. So F A to B. F is defined from A to B. G function defined from B to C are defined by F set of order pair 1 comma A, 2 comma C, 3 comma B. G set of order pairs A comma Q, B comma R, C comma P. Then show that F inverse circle G inverse is equal to G circle F whole inverse. So you see all of you, here we have given, we want to show that this one. Okay, LHS is equal to RHS. So first of all you write this one. F is equal to what? F is equal to set of order pair 1 comma A, order pair 2 comma C, order pair 3 comma B. So f of 1 is equal to what? A. F of 2 is equal to what? C. F of 3 image is equal to B. Similarly, you take into the side F inverse of A is equal to what? 1. F inverse of 2, F inverse of C is equal to F inverse of C is equal to what? F inverse of C is equal to 2. F inverse of B is equal to 3. Okay, all of it. So, here, similarly, G is equal to set of order pair A comma Q and B comma R and C comma P are the order pair. So G of A is equal to what? Q, and G of B is equal to R, and G of C is equal to P. So here you find G inverse of Q is equal to A, G inverse of R is equal to B, G inverse of P is equal to C. G inverse of P is equal to C, G inverse of R is equal to B, G inverse of Q is equal to A. So, here these are the given images, inverse images and their function images. So, we have to find this one. First one. What is here? F inverse circle G inverse. Here F A to B, G B to C. So F A to B, G B to C. So what is F inverse? F inverse is function from B to A, G inverse function from C to B. So F inverse is the function from B to A, G inverse is the function from C to B. Then you find this F inverse circle G. F inverse circle G inverse. So first G inverse is function from C to B. F is function from B to this is function from C to A. F inverse circle G inverse is the function from C to A. So F inverse circle G inverse is equal to F inverse of G inverse of what is the C function? C set this one. So G inverse of P is equal to, so F inverse of what is G inverse of P? G inverse of P is C. This is C. So G inverse of P, P image is what? P image is C. But here F inverse of C image is 2. F inverse of C is equal to what? 2. Then what is the coordinate? P order pair P comma 2. Next F inverse circle G inverse of again P completed Q is equal to F inverse of G inverse of Q. So F inverse of what is G inverse of Q? G inverse of Q is equal to A here. You substitute here A. What is F inverse of A? F inverse of A is 1 is equal to 1. Then we write order pair Q comma 1. What is order pair? Q comma 1. Similarly, F inverse circle G inverse of P completed Q completed R is equal to F inverse of G inverse R. What is G inverse of R? B is there. So is equal to F inverse of B. Okay, all of you. What is F inverse of B? F inverse of B is 3. F inverse of B is 3. Then what is order pair? R comma 3. What is order pair here? R comma 3. Then we write as order pairs of F inverse circle G inverse. So we write order pairs of F inverse circle G inverse. So F inverse circle G inverse is equal to set of order pair P comma 2, P comma 2 and Q comma 1, Q comma 1 and R comma 3. This is the F inverse circle G inverse. What is that? F inverse circle G inverse. Okay, all of you. So this is the LHS of the problem. F inverse circle G inverse LHS of the problem. P comma 2 order pair, P comma 2 order pair, Q comma 1 order pair, R comma 3. Okay, all of you. Next you go for RHS. RHS. What is RHS here? RHS G circle F of this one. So what is G circle? F of, first you find G circle F. So G circle F is mapping from A to C. G circle F is F is the mapping from A to B. G is the mapping from B to C. Then G circle F is mapping from A to C. So G of F of 1, G of F of 1 is equal to G of F of 1 is what? F of 1 is A. What is G of A? G of A is Q. So what is the order pair? 1 comma Q. Next, G of F of A to C. Okay, G of F of 2. What is F of 2? F of 2 is C. G of C. What is G of C? G of C is P. So what is 2 comma P? Okay, all of it. So again, G of F of 3 is equal to G of, what is F of 3? F of 3. F of 3 is B. B. F of 3 is equal to B. So what is G of B? R. G of B is equal to R. Then what is order pair? 3 comma R. Order pair is 3 comma R. Then what is the G circle F order pairs? G circle F order pairs. G circle F order pairs set of, what is 1 comma Q and 2 comma P and 3 comma R. Then here we want to find the value of G circle F whole inverse. G circle F whole inverse, this one. So G circle F whole inverse is the set of this order pair interchange, that is Q comma 1, P comma 2 and R comma 3. This is the RHS. Okay, all of you. You observe LHS and RHS. Q comma 1, Q comma 1, P comma 2, P comma 2, R comma 3, R comma 3. These order pairs are same in F inverse circle, G inverse. So, this is equation 1 and this is equation 2. Therefore, from equation 1 and 2, we write as, that is, G circle, F inverse circle, G inverse is equal to G circle F whole inverse. This is the hence proved. Hence proved. Okay, all of you. That's all. Thank you for watching.